All right, so Unit 1, Lesson 1, Investigation 1. We were talking about inverse and direct variation. Now, we just did an activity where you guys came up with definitions for direct and inverse variation, right? Came up with a definition for direct and inverse, right? Yeah. So, in direct variation, what happens to the independent dependent variable? Okay, so if the independent increases, what happens to the dependent?
Decrease.
Increase or decrease? Increase. Okay? Now, if the independent variable decreases, what happens to dependent? The independent variable decreases, what happens to dependent? For direct. That's what, Victoria?
It increases.
Decreases. Okay? Listen to Victoria, Willie. Okay? All right. So, for direct variation, that's when the independent and dependent variables behave the same. All right? So, it's direct variation if the independent wow, that is very sloppy. Independent and dependent variables behave the same. So that means as the independent increases, right? What happens to the dependent? Does it increase or decrease?
You said
they behave the same, right?
Yeah, so they both increase.
They both increase, good. Or as the independent decreases, the dependent decreases. Now, typically, what letters are independent variable again? Typically, what letters are independent? X. Typically, it's X, right? And what letters are dependent? Y. So typically, it's Y. Now, how could I write an equation where Y and X increase or decrease together? Can someone give me an equation where Y and X increase or decrease together? X plus Y?
Y
equals what?
X.
Y equals X. Perfect, Willie. Okay. So Y equals X. If X goes up, will Y go up?
No.
Yeah.
Oh yeah.
What if I have Y equals 2X? Okay, it goes up faster, right? What if I have Y equals 1/2 X?
It decreases. Like 2.5.
It still goes up though, doesn't it?
0.5.
If I have Y equals 1/2 X, I have, so here's my little quick table. Okay. If I have 1 for X, what's Y going to be? 1/2, right? If I have 2 for X, what's Y going to be? 1. If I have 4 for X, what's Y going to be? 2. So are they both still increasing? Yeah. So this number here can be a decimal. It can be a whole number. It can be a number less than 1. It can be a number bigger than 1. You think it can be a negative number?
No. Well, yeah.
Well, then it would go down.
Well, if it's a negative number, right, then these become negative, but the value of the numbers are still getting bigger, aren't they?
Yeah.
Yeah. Okay. You're thinking of up and down in terms of like money values now, aren't you? Okay. But we're still getting bigger numbers though, right?
Oh, yeah.
Okay, does that make sense?
Yeah.
So, in a direct variation, guys, is anything that can be written like this. Y equals kx. Okay? Where x is the independent variable, right? Right? Y is the dependent variable, and k is what? Oh, it's got to be something. Can't be 0. If it's 0, then y equals 0 all the time. Okay? Well, it's not write it down. It's a number. What kind of number? 2, right? Would 1.5 work? Would -1 work? Yeah, would 9
anything
work?
would Yeah, anything
Would
work.
5,275.373 work? Yeah. Okay. So K is any single number.
Okay.
Right? If it stays the same number all the time, it's called a constant.
Yeah, constant.
Okay? These are variables because they change. K stays the same, so it's a constant. K is actually called the constant of proportionality. You guys see that word before? Yeah, where'd you see it, Tevin?
Mr. Coon.
I ain't never seen that word.
Yes, you did. You said yeah.
Brandon
Brandon said yeah. Brandon, where'd you see it before?
Constant of. I see it here.
You saw it here on what?
It was one of these sheets.
It was that pretest, wasn't it?
Yeah.
Yeah, we saw that on the pretest. So you think that's important? Is constant proportionality something we should know?
Yeah.
Yeah, we should know that. Okay. The constant proportionality is an important term. So, in this equation, x is independent, y is the dependent, k is the constant proportionality. Now, who here is good at algebra? Kevin? I want to get k by itself. How do I get k by itself? Okay, it's being multiplied, right? So what should I do, Selena? Divide both sides by x. If I divide both sides by x, we end up with this. Right? You guys see that?
What?
Okay, you guys see that?
Yep.
So if it's written in such a way where I have y equals some number times x, okay, or some number times y over x, then it's direct variation. Okay? So these are the possible equations for direct variation. Okay. We'll put them in a box. It's always good to box your equations, I think. Draws attention to them. That's for direct variation. Okay. So what could some examples of this be? What's k again? K is a constant. So give me a constant, anybody. 10. I heard 10. Okay. So an example. Y equals 10x. Right? Direct variation. If x increases, what happens to y? It increases too. Right? Now how could I rewrite this one like this? Kevin?
Would it be like k equals 10 over x?
Nope. What's my k here? 10. Karina, what do I do? Good. 10 equals y over x. Okay? Because in this example, 10 is my k. Right? Now, what would this graph look like? What do you guys think this graph would look like? So if I were to graph this, y equals 10x, what would the graph look like? Yeah, y equals 10x. It'd be a straight line. Where would it go through?
10?
You go through y equals 10?
No, it will 10.
Go straight to the middle, right? Because when x is 0, what's y? 0, right? So it goes to this point. When x is 10, what would y be? Or, sorry, when x is 1, what would y be?
10.
When x is 1, what would y be? 10, right? So when x is 2, what would y be? 20. So we're getting bigger, right? Okay. What about when x is -1, what would y be?
Negative 10.
Negative 10.
Negative 20.
Negative 20. So we get a graph that looks like that. Right? Right? Does that make sense?
You know it's dependent when it's somewhat of a straight line.
You know it's direct.
Yeah, it
You
is.
know it's direct when it's a straight line. Now, let me give you a little adjustment here. Okay. What if this x was squared?
It will go up by 2.
Would
so
it still follow this rule as the independent increases, the dependent increases?
yeah, but it would be so
Still,
yeah from 1 and then it'll go to 100 and then 1,000 and then
it would still follow that rule, right?
would it go like that?
Right, guys? It still follow that rule, wouldn't it?
Would it?
So another example would be y equals, we can say like 2x squared. Right? How could I rewrite that one? So this or that, how can I rewrite it as the or? What's my k down here? 2. So we can rewrite it as 2 equals y over x squared. Right? What does x squared make? Remember it. Good. What does x squared make? What does x squared make? What graph? Not exponential. U to the p. But it looks like a u. What is it? A parabola. Good.
Yup, like an umbrella. And then that means it's negative like that. And when it's when it's
Yes.
yeah, the positive
What?
version like that.
In Lapeer, where I came from, they did not use whatever you're saying.
It wasn't a parabola. What do they call it?
Umbrella.
It was something like, it was a simple word.
Okay. An umbrella.
No, like it was like.
Oh. Okay. That's all right. Just if you can think of the word, let me know later. Okay.
Alright.
All right. So, what if instead of 10 times x, what if I had, I'm going to write it over here since I'm running out of space down here, so keep going with this underneath your examples. What if I had y equaled like the square root of x?
Oh, kill 'em.
Would that work?
Would it be positive though?
Yeah, because if this number is 1, what's the square root of 1? Square root of 1?
1,
1. If this number is 4, what's the square root of 4?
2,
2. If this number is 9, what's the square root of 9?
3.
3. As x is going up, so is y, right?
Yep.
So would that work for direct variation?
Yeah.
Yeah, how does that one look? Does anyone remember?
Terry taught me.
Looks like that. Okay. And it doesn't go this way because can we square root negatives?
No.
No.
So no.
Yeah, I would. Now this one would be, since I have no number right here, my k is, since I have no number here, my k is what? 1, right? And so it's going to be 1 equals y over the square root of x.
Oh my lord.
So anything that can be written in this way, y equals kx, or k equals y over x, is direct. Okay? So anything that we can write in that way is direct. Now, all of these direct graphs go through which point? Brandon, all these direct graphs go through which point? What is it?
0.
The center, 0, 0. What's that called? It's an O word. Origin, good. So all the graphs must pass through, bless you,
Thank
the origin. And remember the origin is 0, 0. Okay? Kind of a big point. All the graphs must pass through the origin. Bless you. Must be allergic to math.
Yeah.
All right. Are there any questions? Are there any questions? Okay, real quick. I got two little questions for you. We'll do y equals 3x cubed. And Willie, stop rapping, please. We'll do y equals 3 over x cubed. We'll do 3 equals y over x squared. And we'll do 3 equals y x squared. Okay? And we'll label these A, B, C, and D. So, real quick on your own. Which ones are direct? Sorry, which ones are direct? We'll say inverse. No, on your own. Okay, try and do it on your own real quick.
Done.
Do it on your
Can
own.
it be more than one?
I said which ones
Okay.
are direct. Which ones are direct? Outside of my shop. I feel like a director right now, Christian. I'm outside my shop.
So there, how many wrong are there?
I can tell you that, Willie.
I think.
That limits the effectiveness of the
I
question, though.
know it's 2.
So you think you know? Okay. Haley, you think you know? Okay, hold on.
I don't know. It's my first
Can you help Willie? How many are direct? Haley says 2 are direct.
2.
Yep.
I knew that.
Then why'd you ask?
I was just making sure.
Okay. Well, thank you for checking on Haley.
Thank
I
you.
appreciate that.
Thank you, Aiden.
So basically, what we're doing is we're matching to the pattern, right? Remember, K is a number,
Number K.
right? So raise your hand if you think you know. Which ones or one over there looks like y equals kx?
Look.
Haley, which one looks like y equals kx?
A.
Which one? A. So A is direct.
Yes.
Okay? Y equals kx. Here's my constant, right? Dependent, independent. Good. Now, which one, raise your hand if you think you know, looks like k equals y over x?
None because they
Oh,
both.
that's easy.
Savin, which one is it? B?
No, C.
C?
No, because it has an S on it.
No, it's, yeah.
Which one is it? Brayden, which one is it? Nope.
No, it's neither one. It's B.
C.
Karina? Nope.
A.
None of
A.
them. It's none
Okay,
of
now
them.
remember,
It's neither one of them. Then.
constant k, right, is a number. Right? So number's by itself. Which one of these has a number by itself? B, C, or D?
B.
B has a number by itself, right? Now does it equal my dependent over my independent?
No.
You sure?
Yeah, it does.
Yeah, it looks just like k equals y over x, doesn't it?
So you better
Yeah.
check out.
Well, you gotta be confident. Okay? So A and B are both examples of direct variation.
Yes, I got that.
What do you think C and D are?
Inverse.
Inverse. Okay? And we'll talk about inverse
Tomorrow.
tomorrow.
So B is inverse.
Okay.